Dr. Colleen Hilla.
Have you ever wanted to spend less money on a plane ticket? Do you know someone with an implanted medical device? How many of you checked your cell phone today? Something all these things have in common is the material tantalum. And tantalum is extraordinary. You can get it really, really hot and it won't melt. It's great in electronics. But there's some things we don't love so much about tantalum. It's pretty soft compared to similar metals, and it's difficult to manufacture into parts. So we'd like to take tantalum and add things to it to make it stronger and easier to work with. Things I too aspire towards. But historically, the process for creating a new material is really, really slow. Researchers have taken a metal and they add an element to it, and they add a little more, and they add a little more, and they see how the properties change. Did it get stronger, more magnetic, lighter weight? But if you remember the periodic table, there's 119 base elements that you can add. To make matters worse, some great metals like stainless steel, which you might have in your kitchen or your utensils or your appliances, or Inconel 718, which is heavily used in the aerospace industry, can have up to 14 different elements in them. If you think about all the ways that you could take 14 random elements out of 119 and all the different combinations you could make, and you took just 1 second to think about each one of those, it would take you more than 10 to the power of 21 years. That's one with 21 zeros. Now, I don't know about you, but I don't think I'm going to live quite that long. So not only is this process slow, to truly understand all the materials we could possibly create, it's been impossible. And in the case of tantalum, it's also very expensive. On average, tantalum is 100 times more expensive than common structural materials like stainless steel. Through a traditional process, in order to have enough of a new material to test, you're talking about thousands of dollars worth of tantalum. So we really don't want to mess that up. So what researchers have done is make small incremental improvements that are likely to work, rather than create something brand new, which could be much better, but also could not work at all. What I have done to address this is create a framework where we can use machine learning to rapidly screen hundreds or thousands of these materials per second. This allows us to get rid of all those materials that were truly never going to work. I then use a metal 3D printing process that allows us to print little marble-sized coupons of different combinations. And we can print hundreds of these at once to rapidly and cost-effectively test them. My colleagues and I at Savannah River National Lab can now use this framework to create the next generation of tantalum alloys, where we'll start to see these larger leaps in improvement that we're aiming for. These new materials can then be used to make your phone battery last longer, to make medical implants safer, and if we can make flying more efficient, maybe one day we'll see a drop in those flight prices.